Thank you so much. G'day. Any Australians in the house? Any Aussies? There's a lot of Aussies in Berlin, I find. At least we brought coffee culture, right? You can thank Australians for the good coffee you can get here in Berlin. I'm going to take full responsibility for that. So if you've ever heard of me, and you almost certainly haven't, many, many years ago I wrote this article called The Tao of Web Design, which then no one talked about for about 10 years until Ethan Market referred to it in his very rightly much more famous article that kicked off responsive web design. So I jokingly refer to myself as the grandfather, and possibly the great-grandfather, of responsive web design. But the reason I talk about that is not because I'm conceited. It's not just because I'm conceited, but because there was this time in the late 1990s where the web was really considered kind of a debased form of print. So it's kind of very interesting to follow Brian. It was kind of, we always saw what was wrong with the web compared what was good about print. And we saw all these features of the web, well, not we consider now to be features, which were bugs. So it was this really, we thought they were bugs because, you couldn't control the font size and people could resize their windows. But what we were learning was the web was actually not just print 2.0. It was actually something of itself. And it was really a revolutionary time. And I was very proud and excited to be there and to have a little part to do with it. And maybe more of you were there about 5-6 years later with the kind of Ajax revolution, right? Which really kicked off the idea of web applications. So we moved our models away from just information-based understandings of what the web could do to be much more interactive. And Ajax was really that revolution. And I feel that we're at a similarly revolutionary time in the history of the web. It feels as exciting to me as those other periods. And so I want to try and share some of that excitement with you and hopefully get you to go away and start rethinking a little bit about what the web is and what we can do with it. So what if I told you that the web can work offline? Now, most of us think of the interwebs, right? It's a funny joke and so funny. The truth, but it actually betrays, to some extent, a misunderstanding of what the web is. Because the web and the internet aren't the same thing. The internet is the transport layer, and the web is the application layer that sits on top of that. And yet, for all sorts of reasons, we kind of intertwinkle the two. We don't loosely couple them. But over the last few years, a set of technologies have emerged that allow us to decouple the web from the internet and allows us to do things that we haven't been able to do in the past. So what I want to talk about for the next 45 minutes or so is what those technologies are, but much more importantly, what we can do with them. Now, I don't know everything we can do with them, but if I did, it wouldn't be a revolution, right? Revolutions are kind of times when the unintended consequences of our technologies are the interesting ones. And that's something that's been a bit of a theme over the last couple of days. So, in fact, right here in Berlin are a couple of fabulous folks, Alex Fierke and Jan Lennertz. I think Jan's been around, and they are working on a thing called Hoodie, one of the sponsors, indeed, of this particular show. And earlier this year, or maybe late last year, in the very same journal, a list apart that published Ethan's article and mine, they published a manifesto, the Offline First Manifesto. And they said we can't keep building apps with a desktop mindset of permanent fast connectivity in mind, where a temporary disconnection or slow service is regarded a problem and communicated as an error. Forever we've been thinking, just around the corner we'll have permanent, always on 5G, right? It's not going to happen. We still travel at 30,000 feet. The New York subway is never going to have an internet connection for you, all right? So we've got to get away from thinking that right now the web is crippled or it's diminished because we don't always have internet connection. And we've got to decouple what we build from an underlying need for the internet. Now that might sound kind of how can you possibly do that? Well, I'm going to tell you how. And I'm going to tell you stuff that actually works. And frankly, I'm astounded in some respects that people aren't doing it already. And I have a couple of words to say about why they aren't yet, but hopefully I'm going to change your minds about that over the next couple of days. So what we're going to cover for the next little while are 4 technologies. We're going to cover web storage. We're going to cover the AppCache, which you may have heard of. You may have heard of being a douchebag. We're going to address that particular issue. I'm going to talk about offline events, how we can find out from the browser, is it offline or online right now? And then I'm going to look at actually a couple of other cool things very briefly that I love, that I just don't have time for, plus what's coming next. All right, so we'll start with web storage. So until HTML5, we just haven't had a way to persist users' data. Well, we've had a couple, but they've been terrible, right? We could store them on the server, which requires all that to and fro with the server, which is a lot of work and a whole lot of other problems we're going to touch in a minute. Or we can use cookies in the browser. Who likes cookies? Well, I don't mean the cookies you eat. Yeah, right. Development with cookies, like it's a pain, it's incredibly insecure, all right? There's a lot of work. All the sorts of things that we heard from James a couple of sessions ago about insecurity are all about transfer layer insecurity. And cookies and storing stuff on the server both require that, right? And both of them are a ton of work, right? Because you've got to do all this logic on the server, you're probably working in a different language, you've got a whole different team, right? Just to do some simple things some of the time. So as we build more and more sophisticated web applications, we need to keep data around in our servers, in our clients, in the browser, and not constantly talk to the server. So I'm going to talk about two closely related technologies that help us do this, to keep information in the browser and not have to talk to the server at all, hopefully. The no back-end architecture is what Jan and Alex refer to it as. Or if we do, we can minimize the amount of traffic we need to send to and from the server. Because the truth is, on top of it being a security problem, on top of it being a ton of work, the single slowest aspect of your application will always be, by orders of magnitude, the network, right? Anything that goes on the network is incredibly slow. And so we've got to try and minimize what we do on the network for all kinds of reasons, but not least because of performance. So, we spend all this time trying to shave milliseconds off what we do in the DOM, and then we don't mind pulling in hundreds of different resources from the internet, right? All the time, every time someone visits our website. So if you care about performance, hopefully the next 25, 30 minutes is going to help you with that as well. So we're going to look at two very closely related technologies. One's called session storage, which allows us to store data just during a session and the browser throws it out afterwards. And the other is called local storage, which, like cookies to an extent, allow us to keep data in the browser in between sessions. So every time a user comes back, that data's there for our JavaScript to get access to and take advantage of. All right. So what is a session? We're going to look at session storage. So a session, I could go into great detail, but basically it's the idea of a window or a tab, or technically speaking, a top-level browsing context, if you really want to know, associated with a fully qualified domain, right? So in a tab or a window or while it's in a domain, you've got a session. You go away, you come back, you've still got the session. As soon as you close that tab or window, the session is over, that data is gone forever. Right? So what good is it? Well, a lot of it's about security. We can maintain very sensitive information during, say, a transaction, going through a shopping cart, when someone's signing up for a service, when you're giving you details, while it's in the client before you finalize that transaction with the server. We can create multi-page and multi-step forms or processes where the data is stored in the browser from step to step to step. And in a lot of ways, very importantly, it moves the heavy lifting of protecting sensitive data from we as application developers to browser developers, right? Because frankly, none of us are good enough at security, right? None of us, should you write your own crypto library? No, right? We don't know enough about it. So the more we can move that on to browser guys, the more we should do that. Because those men and women are really, really good at this, right? And you rarely, if ever, see genuine browser security problems. You see a lot of stuff happening on servers and big banks, you see them in big retailers, right? Because even their teams aren't good enough, right? So that's one of the big things this does for us. So how do we use it, right? So I'm only got a couple of points where I'm going to talk a little bit about JavaScript, so don't be too afraid if you see some JavaScript. I know there hasn't been a ton of that on the screen the last couple of days. Right? And pay attention because session storage and local storage work identically. The only difference is one lasts just for a session, the other lasts for forever, basically. Right. So session storage is a property of the DOM's window object, and it's basically a simple key value database namespaced to a particular fully qualified domain. Right? So that domain, every single domain gets its own local storage within the browser, or session storage, or local storage. And what it does is it stores key value pairs, so if you've done any programming much at all, you'll be familiar with that. And each pair is a piece of information which we identify with a key. And both the key and the value are strings, which we'll get back to in a minute. And then we use setItem on the session storage object to store data. It's really straightforward. So here we're just populating a variable with something the user's filled, and then we're storing it in an item in the session storage called name. That's the key there on the left, name. On the right is the value that we're storing. Right, so there it is. Now what's really cool about this is we haven't had to create a database, haven't created tables, haven't created rows, haven't created items. We've just said set an item. Now if the item doesn't exist, the browser makes it for us. Woohoo! If it does already, it just replaces the existing value, right? Which is really cool. Like, it's a very simple technology to use. And now it's going to remain there for us to use again in our JavaScript until the user closes their window or their tab. All right, but you know, there's not much point storing data if you don't get it back. So what can we do about that? So we use a function called getItem, and that allows us to get an item back based on the key value. Right? So here we are, we're getting it back. We're doing a getItem on the session storage, and we're saying, give me the item with a key called name. Right? There's that little string name. And we gets it back, puts it in our variable. And that's it. You now know how to use session storage and local storage. That is all you really need to do. There's a bit more to it. I'm going to touch on a little bit of it. But right now what you've done is you have enabled yourself to write an application in JavaScript that stores anything you want about the user, any of their input, maybe some of their preferences, maybe some other things you can glean, their geolocation, other things that you can get, and you just store it. And when they come back, or while during this session, it will be there. Right? That's kind of liberating, and it's such a simple thing to do. So I want you to start thinking about, well, what can I do? What can I do if I can maintain information about a user over a period of time? All right, so that's during a session. And there are certainly pieces of information we just never want to keep around indefinitely, because on top of everything else, if during a session someone else got hold of your device, they could use developer tools in the browser to actually inspect what's there, right? So that's the biggest single security challenge here, right? But someone actually physically needs to have a device to get at that data. But as soon as that window's closed, it's all gone. Awesome. However, you know, we really want it sometimes to be information available to us as developers in between sessions. Someone might come back days and weeks, months, hours, or minutes later. We want to resume a shopping cart. We might want to resume a transaction they were doing, right? And we can do that by storing data about that and then restoring it in almost exactly the same way, right? So instead of using session storage, we just use local storage, and all the methods are the same on both of them. So we set items and we get items. Just a couple more things you might want to know about. So because local storage persists effectively forever, you might want to throw stuff out, right? And we can do that very simply with the remove item, and we give it a key. So give it a key, and we'll remove that item. It's gone forever. And then if you want to throw all of it out, if you don't want to keep it around, you can call clear, and that's just going to clear the entire database. But, you know, that's it. It's gone. So you've got to be a bit careful. That's the nuclear option right there. Okay. So what good's local storage? Well, this is what I want you to really start thinking about, what it enables us to do. So we can maintain the subtle state. You know, maybe a user doesn't kind of, you know, tell us things that they like, but we can glean from the way they're using our application. Maybe they've opened a set of tools. Maybe when they come back, we'll open them again, right? Maintain that state. Because the web traditionally is stateless, right? And so almost every time we start a session, we're starting from scratch. So this allows us to maintain state. But to do it without having to talk to and from the server, without having to create accounts, having someone create an account, log into that account, it can all happen transparently, without friction in the browser. So things like user preferences, are they logged in or not? As I said, it drastically reduces that need to communicate with the server, to do a lot of logic on the server. In a lot of cases, we can just do something with no back end at all. All right, a couple more things. This gets a little bit more technical, but this is a really cool feature. And if you're a developer, hopefully you will like this one, right? So we can even create an event listener that allows us to listen for when local storage has changed, right? So you might have multiple windows open in the same domain, so they're all sharing the same local storage. And when one of the windows changes local storage, if I've got an event listener in another window, it will get a storage event. And we can have an event handler here. It's called storage changed, right? So if you think about it, This has got a lot of kind of value beyond simply storing data. In the past, if you want to communicate between different windows, you might have to go via the server, right? So you're requiring a lot of logic and a lot of application complexity just to talk between two windows. Or you can use post message, but that means the windows have to know about each other, right? In this case, they don't have to know about each other. There's no server involved. We just use a simple event listener. And now we've got all our windows talking to each other, which personally I think is amazingly cool, right? That's worth the price of admission alone, that one, I reckon. All right. And just very briefly, what you get passed in is the key of the item that's changed, what it was, what it's become, and the exact URL, right? So the local storage is basically any path, any asset, any resource within the same fully qualified domain will share that local storage, right? So it's not just the same page open in different windows, it's any page open right across that domain can listen on these events and use the same storage. Hopefully some of you are starting to see the possibilities, maybe based on some of the hard work you've had to do in the past to do some of this stuff. It's all in the browser with JavaScript now. I think that's awesome. All right. I've talked about that. But one use case might be you might have users logged into your service across multiple windows, right? And when they log out in one, they're assuming they're logging out right across, right? You don't want them to be sitting there with still logged in the other windows. So in the past, we'd have to maybe poll the server doing long polling or some sort of Ajaxian kind of communication. Now, all we have to do is listen on that event changed, that storage event, and when it changes, we can log out in all the other windows as well, right? That's one of, I think, almost countless examples of what we can do. And as I said, post message is kind of for this, but post message actually requires the windows know each other's existence. One of them has to have spawned the existence of the other, or it's in an iframe. In this case, they're completely independent of each other. They don't have to know anything about each other, which to me, again, it really simplifies our architectures and opens up all kinds of possibilities, right? Okay, as with all technologies, there are gotchas. And I've told you it's very quick to get up to speed with. It is, that's true. But I think often what happens when we learn a new technology, and Seb started yesterday morning talking about how, we always want to learn new things, but it's hard and it's scary. And I think actually sometimes it's not the concept. The concept's easy. It's you run into these little implementation details or things that don't quite work as you might expect. And often the 101s, the X-Rocks kind of articles, they tell you all the how to get up and running with the tech, but they don't tell you what comes next. What's that little problem you're going to face? And that's often fine when people's adoption rate is like, yeah, it's really cool, and then, right? So I'm going to hope and try and stop that bit. So what are a couple of gotchas I think you should know about? So there's a storage limit. So basically, there's a 5 meg storage limit per domain. All right? But if that exceeds what you need, like if you're doing lots of things with video and audio and images and things that are large, or large number of things, then there's a thing called Indexdb, which I'll talk about at the end of the presentation, that you can use in a similar way to local storage to get that offline storage that has much greater capabilities. All right? They're also synchronous, right? So when you read and you write, that blocks the execution of the rest of your JavaScript, which makes them really easy to use. As you saw, var x equals get item, right? Really easy, no callbacks, no event listeners on finish. The problem is that if it's a really large file you're reading or writing, or a large number you're reading or writing, there may be a performance impact. And actually, a lot of people have kind of jumped up and down and got excited about that. But the truth is, in the real world that I've seen over several years, it's very unlikely to impact you. So it's worth knowing about, but don't kind of get head up about that. All right? Just something worth knowing about. One more thing that's really worth knowing about is that all the data we store is stored as a string. All right? So whatever you store needs to be converted to a string, and that includes floating point numbers and dates and objects and all sorts of things like that. If you're storing a Boolean preference like on or off, or you're going to use a Boolean value. So all these sorts of things that we're storing need to be converted to a string, but as always, JSON is your friend. All right? So basically, very simply, we can just basically stringify stuff as we write it. On set item, we just stringify whatever we want to write, and on get item, we just parse it back out. And I go so far as to say, you wouldn't want to do that every time you use set and get item. Just write a helper function. So you just write a function, write data, and in it, you basically use JSON to stringify and parse. Right? But even still, a very simple process, really. Okay, a couple of more things about this. So we're restricted to a single origin. You can't talk between different domains, or even subdomains of the same domain, right? So you might think, well, that's a bit restrictive, but what about john.wordpress.org and jane.wordpress.org, right? You don't really want those to be able to talk to each other necessarily. Way back in the day, Firefox had the concept of global storage, right, which is just a storage place that anyone could read and write to, but it sounds like a good idea until you think about it. All right. It's been deprecated. All right, so local storage is awesome, but we have been able kind of to do that in the past with cookies, all right? Or even flash storage. And I mean, flash is kind of, it's a bit of this is sort of retro 8-bit kind of, we're sort of feeling nostalgic for flash, right? Which is awesome, right? Because I remember flash storage, was one of the things that allowed us to do this back in the day. What's nice about this is it's standards-based and it's in every browser, more or less, right? But it doesn't make our websites work when the user's not connected to the web. That's like the holy grail of the web. So our next technology, that's exactly what it allows us to do. It allows us to have websites that work even when you're not connected to the web, right? Or most important, not connected to the internet. So how does that work? Well, I just want to say a couple of things. So I alluded to AppCache being a douchebag. So many of us have read this particular article, and I know Jake very well. In fact, we had him come speak in Australia at our conference only last week. And the thing about that article is, unfortunately, it just seemed to be like an excuse all these people had not to adopt AppCache. Oh, it doesn't work, it's all broken. A bit like the myths we heard earlier about WebRTC. So if there is a takeaway from this, forget all the stuff the substance. If I had one takeaway for you is, don't listen to naysayers, right? Because I have this little saying, like people say something's not ready for prime time. So my philosophy is if it's ready for prime time, the boat has sailed. And again, that's what we heard about WebRTC this morning. So seek out things that maybe aren't quite ready for prime time and explore them and use them and get ahead of the curve. And the truth is you are doing that. You're the kind of people who do that because you're here. You've chosen to invest the time and money and effort to be here, and well done to you for that. But take that away. Forget everything else I'm saying, right? Don't listen to people saying, oh, it's broken, it doesn't work. And it's like, forget about it. Right? Think about what the prospect it is. So in a way, Jake was right in many respects. Well, I don't think so. So let's have a look at the Urban Dictionary definition of douchebag. All right? You may not be able to see that. So someone who has surpassed the levels of jerk and asshole, however, not yet reached fucker or motherfucker. See, I can say this because, I'm German, right? I don't know, German, English, I don't know. Anyway. Other people have sworn in this conference, so I don't feel too bad, right? And it's in a dictionary, and we all love dictionaries. How many times are dictionaries? The Herflow was talking about dictionaries. We love them. Urban Dictionary says, all right, not to be confused, funny spelling there, but we'll leave the Americans out of it, with douche. Don't look up that. I think this is really unfair. Douchebag's pretty harsh, right? So here's my take on it. Because the thing about douchebags is they do it because they're douchebags, right? They do it because they want to mess with you. They're almost fuckers, right? Their motivations are impure. They love to hurt you. And I don't think AppCache is like that at all. So who knows Viz magazine? I bet John does. Yo, English people, any German folks know Viz magazine? So Viz came out of, I think, Newcastle University, and it was a university newspaper that came out. It's very satirical, it's very low humour, but really funny. And they have this marvellous character, he's my favourite character, called Mr. Logic. And this is the best image I could get. So Mr. Logic is Mr. Logic. The subline there is, he's a pain in the ass. And the thing about Mr. Logic, he does exactly what you ask him, exactly how you ask him, with no nuance or subtlety. Right? And we all know those kind of people. They're very logical. They're not malicious, but they are a pain in the ass, right? So AppCache is like that, right? He doesn't want to hurt you. You asked him to do something, he's doing it. Why are you so unkind? So what we need to do is we need to understand Mr. Logic's logic. We understand AppCache's logic, and that will help us overcome this perception that it is a douchebag, right? So what I'm going to do is going to tell you how to use it, very briefly, and then we're going to look at some of those little rules that Mr. Logic follows, even though what? Anyway, so we all know browsers make caches, right? But in the past, we've been able to use HTTP caching and to tell it, well, maybe you could keep this for a while, but we haven't been able to say, you must keep this always, right? So what AppCache is about is basically telling it what it must and must not cache, right? And what's really important with it is it actually allows us to build web apps that work when the user is not connected, right? So I'm going to take a little digression, right? We sort of have this kind of idea of the web versus native, right? And the native people always going on about how awesome native is, and we poor web, we feel like the distant cousins, right? Sometimes. So here I want to install an app, right? I've got one of these awesome native apps I've heard of, right? So I have to go to the App Store. I have to search and find the app, or maybe and then I have to choose to install it. And then I have to give it some sort of credentials, like a password. And then it downloads, and let's face it, most apps are pretty big. I mean, we complain about 1 megabyte homepages on websites, but most apps are like orders of magnitude bigger than that, right? And then it downloads, and we have to open it, right? It's about 7 steps, all right? How do you install an app from the web, and a web app? Well, you visit a URL, bang, done. The unfortunate thing is we kind of still need that web connectivity, right? Because when we go back to that, unless we've got the web connectivity, it won't open. Well, this is what AppCache does. This is its magic. It allows you, as a developer, to set it up. So once the user has visited your URL, it's installed. They don't have to give permissions or give you passwords. It's installed. It's genuinely magic. So I'm trying to convince you it's really worth exploring, despite the pain points, right? And then you might just say, I don't really build apps, I got informational sites, but actually really helps with performance as well. All those assets that sit around, JavaScript and CSS and images that never update or update infrequently, you can basically tell the browser, keep them around forever and don't bother pulling them down again, right? So there's all these amazing benefits. So I hope that convince you how amazing they are and also help you over that curve and to convince you AppCache is not a douchebag, he's just a pain in the ass, right? So how do we do this? So first we create what's called an AppCache manifest file, and then we link to this from any HTML document, and then we are aware of a few gotchas. All right, so let's quickly get through it. That's what a manifest file looks like. I'm going to go break it down in a minute, but look at that. There's no JavaScript, there's no CSS, no HTML. It's just a simple set of instructions to a browser to tell it a few things about caching. So what are those things? All right, so we have a cache section, and what that does is basically with a relative or absolute URL, we specify explicitly the resources that we want the browser to grab and always cache, all right? We can cache across domains as well as within a domain. And that's what it might look like there. You've got some partial and we've got some full relative and absolute URLs. And that's basically telling the browser, these are the resources I want you to download and keep locally and never bother getting off the web again. Just keep them around in your cache. All right, the next thing we might want to do is tell the browser content that we don't want it to cache, right? Like a search result, maybe a sign-up page, things that we really need them to either fetch freshly every time or to be connected to use, right? So basically we create this network whitelist, it's called, and basically when the user's online, the browser will fetch them, and when they're offline, you get an error, right? So as you as a developer have to worry about that. Right? But the idea is to basically tell the browser, never cache this, including in your own private cache. Don't cache it, right? Okay. And so very briefly, we can specify either a fully qualified resource, or we can have partial patterns. Like we say, anything inside this directory or subdirectory, don't cache anything there, all right? There's also this special character, the asterisk, and what that basically says is, anything we don't expressly put in the cache section of the document, of this manifest, treat as being in this whitelist, right? So if I don't tell you to cache it, never cache it. Always get the online version, all right? And as I said, these apply both to the browser's internal caching mechanism as well. So it trumps things like HTTP caching or any cache algorithms the browser itself has. All right, so this is what a network section might look like. And most of the time, you're probably just going to use the asterisk. Okay. Lastly, and I'm not going to go into detail, but I'll refer to my book. In fact, I'm giving a copy of my book virtually at the end of the presentation, which covers all this in excruciating detail. So I won't go into this so much. But basically, you can provide fallbacks so that when the user is offline, if something hasn't been cached, then it will use that fallback resource, right? So it's not for error 404s and things like that. It's only when the user's offline, if these resources haven't been cached, here's a fallback, right? Okay, so there's a manifest. We've got a cache section, we've got a network section, a fallback section. It's really straightforward, right? That's a simple process. And as I said, no JavaScript, not even CSS and HTML, right? Even your boss could do it. Now, how do we use it? Well, this is even easier, right? All you do in the HTML element of your document, you use the new manifest attribute, right? Manifest equals, and give it a URL. Relative or absolute, and it's telling the browser that for this HTML document, here's the manifest I want you to use to build the app cache, right? And of course, multiple documents can all point to the same manifest file, so this is how we basically build up an app cache of resources, including HTML documents. All right. This is the bit you've got to worry about. So we spent about 4 minutes on how it all works and 1 minute how to use it, and then most of the rest of the presentation is actually going to be the gotchas. This is the bit where Mr. Logic is a real, But once you know about these 3 or 4 things, right, it's not like they're browser bugs. It's not like the old days of Netscape 4 versus IE4. Anyone remember those days, right? Or 6 and 5. It's not the browser bugs. They all do exactly the same thing. They all work as advertised. It's just that some of it, it's kind of some very weird design decisions. But once you know how they work, you can get around that. Okay, so what are some of these gotchas? I've mentioned this briefly, but once a resource has been cached, it's in a cache section, then it's going to be, the browser never validates that again, never checks online whether it's been updated, right? It's always going to use the cache version. So that stops, conditional HTTP gets. It kind of increases performance dramatically. But, what if you change your JavaScript, right? How do you manage that? Well, you can't simply update a file like a JavaScript file, CSS file. Right? What we have to do is we have to actually update our manifest file. Right? So we update our manifest file, and then the browser goes and reloads and rebuilds the app cache. But in order for your user to see the new content, the user has to reload again. Right? It's like, what's that about? I mean, that's, all right, there's logic to this, right? So why does the user have to reload again to get that new cache, right? Well, think about the flow of using a website. So the very first time you come to a website and the browser looks and sees there's a manifest and it builds that app cache. It's awesome. It's got it stored there, right? The next time it comes back, the first thing it does is it sees there's a manifest, and it instantly pulls all the resources out of the cache, and it throws them on the screen, and that's why you get this incredible performance boost. There's no HTTP traffic at all. Before it doesn't talk to the server at all, it just completely draws itself out of all the resources that it's saved, right? But because, things change, at that point, having drawn all of the content, it then goes and grabs the manifest and says, oh, I'm going to check, I'm going to what's technically called validate the manifest. And I'm going to revalidate the manifest. Oh, okay, there's been an update to the manifest file, I'll get the new version. Now, of course, maybe seconds are going by, right? Because all this is over the network and it's pretty slow. And then it says, oh, look, this JavaScript file has changed. So I download your megabyte of JavaScript, because come on, be honest, most of you have about a megabyte of JavaScript on every page you build, right? So that takes more time. Meanwhile, the user's happily filling in forms and clicking, and what's supposed to happen? Boom, reload the page? I mean, it's not something we're used to happening. So even though initially it looks like kind of really counterintuitive, it's not. It's just a really hard problem. What do? Like, refresh the page hard underneath someone? No, the design decision has been that new cache is only used the next time the user loads the page. Now, there are ways of getting around this, of alerting the user to maybe there's been an update, and then the general design pattern is asking them, do they want to refresh the page? And in my book, I go through all the code of how to do that. It's really actually not that complicated. It's just that if no one's explained that to you, initially that looks like a really weird thing. Right? And so people often find they've updated and that's it. App cache doesn't work. It's a douchebag, right? It's not a douchebag. He's really logical. And sometimes it's not only logical, it's the right design decision, right? The user doesn't want having everything swapped out from under them. You cannot solve that any other way. Right, overall, like you as a developer can choose, okay, I'm going to force to refresh the page. Anyway, as I said, that's in my book, so I'm not going to go into more detail. Okay. So you see, he is logical. I don't think he's malicious. Well, not all the time. All right. So the next one, it's worth really knowing is that every resource you want cached has to be explicitly cached and has to be in a cache section with that URL. All right? So things like images in style sheets, you might naively assume, well, there's an image in a style sheet. The style sheet's in the cache section. That'll get cached. No. All right? Similarly, something that's being generated in JavaScript or an add-imported style sheet, none of those get cached unless you put them in the manifest in the cache section. All right? So once you know that, that's not that much of a problem. There's one exception to that, which is that any HTML document that has a manifest attribute in it is automatically added to the AppCache associated with that manifest. I'm going to talk about that again just briefly in a minute. All right? I've actually got a tool online. It's called Manifester. It's a little bookmarklet that really helps you just go and find all the resources in a particular page and builds an AppCache manifest for you. But it's just worth knowing that naively, you might assume anything linked to something will be included in your AppCache. No, it's got to be expressly included. All your JavaScript, all your CSS, all your images, anything you want to be part of that AppCache has to be explicitly there, right? We talked about this a bit, but cached resources don't have to be in the same domain, which is pretty awesome. But there's an exception that over TLS, they all have to come from the same domain, all right? But the funny thing about that, not funny as in ha-ha, but it's too restrictive in some ways, right? When we're moving toward this kind of TLS everywhere world, which is coming, we've got CDNs, we've got all these different endpoints for our resources. That's probably too restrictive. So in fact, Chrome, or the Blink engine, ignores that. You can actually cache across domains even over HTTPS, but it's only in the Blink engine, right? Okay. Probably too much detail. Lastly, in this one, the master entries. So, as I mentioned, any HTML document with a manifest attribute in the HTML element will be cached, right? You don't have to include it in your manifest, right? Think of your Wikipedia, right? Do you really want to list 100,000? No, right. But here's the problem. You can't override that, right? You can't stop the browser putting that in the manifest. So imagine you've got the front page of a newspaper or a news story. It's changing frequently. It's automatic. That HTML document is automatically added to the manifest, to the AppCache. But every time the user goes to the web page, they're actually getting the last version of that, right? Which is like really not what you want. So this here's where I cover how you can actually deal with this kind of stickiness problem in my book. But to be quite honest, AppCache is called AppCache for a reason. Like it really was designed for applications. So things that aren't reliant on quick, fast-changing HTML, right? So you'll probably find that if you build something that's more application-like, it works better than if you build something that's more informational, particularly a fast-changing or constantly changing website. So that's probably worth knowing. Okay. Another little, this one that, actually, to tell the truth, AppCache can be a bit of a douchebag sometimes, right? There's a couple of the things that it does. It just starting to feel like, what are you doing? All right, so one of them is if even one of the resources that you link to in your manifest doesn't exist, then the cache doesn't get built, right? So if it's the first time you come, it never gets built in the first place. And if it's a subsequent visit, this is even worse, the new one doesn't get built. It just keeps using the old one, right? And it's completely silent, right? It's very hard to debug this. It might be a temporary outage over the network of a resource, right? So this is where you probably want to build who does some instrumenting in their JavaScript and it phones home and reports back bugs and things like that. I would start thinking about including the cache failure in that. And so there's actually some JavaScript that you can listen on for when your cache fails. All right. So that's really worth knowing, right? But this is where Jake really has a point, right? This is an utterly unintuitive feature. It's not like an unintuitive feature that actually has sense. This is one I have never been able to find any logic for. So if you've got logic for this, if you can explain why it's designed like this, please come tell me, right? I need to know, right? So if a resource in your HTML document, you've got an image here, right, or a JavaScript file, it's in your document, but it's not in the cache section of a manifest, so your document's got a manifest file, you've got an HTML document, you've got an image in there, that image is not in your manifest file in the cache section, and it's not in the network section, then it's treated as being a 404, right? Even though it's there. even though the browser downloads it. And this is by design, right? And for the life of me, I've never been able to work out why and how they designed it like that. Anyway, so the secret to this is quite simple. You basically just use that asterisk in your network light list. So in the network section, have an asterisk, and that basically says, if it's not in the cache section, just always get it online, right? And that overrides this problem. But it's genuinely a baffling design decision. I've never been, but this is one of those early gotchas that people run into. Our AppCache is broken, and again, they walk away. All right. So as I said, let's not think of him as a douchebag. Let's think of him Mr. Logic. He's got a set of rules. He didn't make these rules up. Right? Maybe the guy who made the rules up is the douchebag. But he isn't. He's just following, he's following what someone's told him to do. So let's be a bit kinder to Mr. Logic, to AppCache, because he really does allow us to do some pretty amazing things. And the first time you build something running off a server or local server, and then off your local host, and then you kill the server, and you can keep using your application, you will find it genuinely magical. All right. And the other thing is it's really widely supported across browsers. Pretty much every browser and device forever except IE, which started in 10, supports it. And of course, the fallback's great. Don't worry about it, right? It's a new feature. It's progressive enhancement all the way, right? It's no problem with older devices and browsers. All right, a couple of things I'm going to very quickly get through because I haven't got many minutes now. Or is it going up? It's still going down. That's good. All right. There is a little bit we can do in JavaScript and the DOM. We can't rewrite the AppCache in the DOM. You can't say, look, remove this and put this in. It's all got to come from a manifest file. But we can listen on events. We can detect things like, is there a new version of the cache? And then we can maybe ask the user, do they want to update to the newest version? All right? Which is a pretty common pattern they'd expect, right? As I said, this is all detailed in my book. And it's not an ad for my book because I'm going to give you my book, right? I just want to tell you what's there. All right. Okay. So it does work. He's not a douche, but he is a bit of a pain in the ass, right? And it has its quirks. But it is amazing when it's used well. So I really encourage you to go out and explore it. And don't fall down in that first 15-minute period where it either doesn't work or does something weird. If you give it a couple of hours, you will literally be able to do something you've never been able to do, is to have your website or application work for a user when they're completely disconnected from the web. All right. So one more thing that we can use right now, and then a couple of things coming up. Very, very quick, though. So we all talk about responsive web design. So when I wrote that article, I actually used the term adaptive web design. And to my mind, I think we need to be designing beyond simply screens, and that's important, and that's good. But there's all these other cues we can get for the user from the context. And there's geolocation. There's gyroscopes and accelerometers. There's all sorts of things, and I've done some experiments and written about that. But one of the things we can do is adapt the user interface based on is someone online or not? Why would you give them a submit option when they're not online, right? So we can do this in two ways. We have the online property of the navigator object, so we can just ask the navigator, are you online? True or false, or we can listen on events as well. So I'm going to quickly cover those. So we can use the online property, and that will be true when the user's online and false when it's not. And so we can update some controls like this. So very quickly, are we online, true or false? We grab all the submit buttons, we iterate over them, and we set their enabled state to true or false based on that, right? It's a really, really simple thing we can do. There's lots more we can do, but that's a simple example. But the truth is, we may want to change the user interface as the user goes online, offline, as their context changes. And so what we can do is actually listen to an HTML5 event called the online and offline events, right? So we've got an event listener, offline, event listener, online, right? And we just basically call a function when the user's online or offline, right? And we can respond instantaneously. We can kind of disable an upload button, or we can give them a warning. You seem to have gone offline, but we're going to save locally until we're back online, right? There's all sorts of ways you could use this. So again, even if you're not a developer, start thinking about, how can I make my user's experience better? Because that's the point of all this technology, right? At the end of the day, we're trying to make better experiences for our users. So hopefully, if all of this has been 95% blah, 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 douchebag, at least some of it's going to be, that's really cool. I can think about what we can do now to make a better experience, right? Okay, lastly, what can we do, right? So Indexdb, I mentioned, like it basically overcomes all the problems that we saw with local storage. So I'm not going to go into details on that. It's there, it's widely supported now, you can use it. The file API is really cool because we can actually grab local files. Well, the user can give them to us. We can get details like their file name and their last modified date, but we can also even read the contents, maybe display an image. Twitter does that really well, actually, when you update your profile. When you grab the local file, it instantly allows you to work with it, and only afterwards do you submit it, and then it talks to the server. So it feels like so much faster an experience. So what I recommend you do, just go and update your Twitter profile and in the browser and get a sense of just how quick that feels because they're doing exactly this, right? And again, all that's covered in my book. And lastly, what's coming next? Well, so AppCache is probably on the way out. It's going to be there for a while. I still think it's worth, don't not explore it for that reason. But it's being replaced largely with a thing called service workers. And it's basically allows us to build really sophisticated offline apps. You can think of it as a way, as a proxy server installed in the browser for your domain. And you can write event handlers for fetch events, right, in JavaScript. So basically you can write little JavaScript that will detect when a user's fetching something, and instead of passing that traffic back to the server, maybe because the user's offline, or maybe they've already made that request in the last 10 seconds, you can then respond to that. So you're basically intercepting that traffic in your own domain, in the browser. And to me, this represents an enormously exciting prospect. So this stuff really isn't ready for prime time, but it's going to be, very soon, it's going to be in Chrome with the flags off, currently in Chrome and Opera and Firefox with flags turned on. So it's coming, and it's really exciting. So all that is some next level shit that I think you can look forward to. So hopefully I've excited you about some of these technologies. Even if you're not a developer, think about what can I do as a designer, as an experienced person, whatever it is, to make my user's experience better. But most of all, I guess, step back, take that blue pill, and realize that the web and the internet are not exactly the same thing. We need to decouple the two of them in our own minds. We've got to see them for what they are. And only then can we really start taking advantage of the true power of the web. So thank you very much for having me. The offline web is a reality today. You should be using it. I really reckon that's the case. And then there's your little gift at that URL there. You can grab a PDF of my book, and thank you very much. Oh.